Yeah, Sofia. Shaf assigned us a task. We need to prepare 3 types of cakes. Then how?
Really? Let's take a look at the sheet.
So expensive. How about we bake ourselves?
Let's go. Oh, I just said we can bake the cake at home.
Oh, good idea. Why not we do chocolate indulgent cake, chocolate cake and red velvet cake? Alright? Sofia, I think we have the ingredients at home. Flour, milk and egg.
Yeah. But how many cakes can we bake for the 3 types of cake?
How are you? Class, when you guys absent, madam teach us about Gaussian elimination method. Why not we use that method?
Good idea. Gaussian elimination method? What's that?
It's okay, Ayah. We can search at home.
Introduction to History of Gaussian Elimination Method. This is the fun facts of it. Basically, Gaussian elimination method is named after the German mathematician called Friedrich Gauss, which is 1777 until 1855, who systematically described and used Gaussian elimination method in his work. While Gauss did not invent the method, his contribution to its formalization and his extensive use of it in various fields of mathematics and science, which is notably in his work on least square approximation, led to the association of his name with the method. Gauss' exposition provided a clearer, more systematic approach to solving system linear and helped cement its importance in mathematical computation. This is the fun facts of the history of Gaussian elimination method. Second fun facts about the introduction of history about Gaussian elimination method is Newton described a process for solving simultaneous equation in his unpublished notes, which later authors applied to the linear equation. Then Euler did not recommend this method, and Legendre called it as ordinary, and Gauss referred to common. Then the method is now known as Gaussian elimination. Then Gauss' name became associated with is due to the specialized notation he devised for least square calculation, which was adopted by the professional computers. This notation allowed elimination to be viewed as a sequence of arithmetic operations, optimized for hand computing and eventually described using the matrix.
The Gaussian elimination rules. The first rule is interchanging 2 rows. The next one is multiplying a row by a constant, and lastly, adding a row to another row. Next, I will present about how to do Gaussian elimination method. The first step is change the given system of linear equations to an augmented matrix. Second, use elementary row operations on the augmented matrix until we get a row echelon matrix. Step number 3 is convert the row echelon matrix to a corresponding system linear equations. And lastly, solve the system by using back substitution.
Oh, like that. Now I understand what is Gaussian elimination method.
Me too.
Tomorrow we meet Yaya.
Yeah.
Okay. Already late. Where's Yaya? I don't know. Yes, I get the answer. Oh really? How you solve it?
Let me show you the work solution.
Wait, before that Yaya, actually I'm not understanding our problem statement. What is our problem statement actually?
Let me explain about this.
Okay.
quantity of cakes that can be produced for each of three types of cake using a constant ratio of three different ingredients. The second purpose is to apply the Gaussian elimination method to solve our real-life problem. Our problem statement is the class representative assigned us the task of bringing three types of cake for the end of year banquet. We went to a cafe to order the cakes, but all the cakes there were too expensive and exceed our budget. Therefore, we decided to make the cake ourselves using the ingredients we had at home. But how many of total of each type of cakes that we can do by using a constant ratio of the three ingredients, which are eggs, mix, and flour?
Oh, like that. Yeah. Then how you solve?
Let me show you guys the word solution.
Given every cake has same three ingredients, which is eggs, cake flour, and gallon of milk. You are given 44 eggs, 56 units of cake flour, and 70 gallons of milk. Let's say X is chocolate cake and needs 2 eggs, 4 units of cake flour, and 1 gallon of milk. Y is red velvet cake, needs 3 eggs, 2 units of cake flour, and 1 gallon of milk. Z is chocolate indulgence cake, needs 1 egg, 2 units of cake flour, and 3 gallons of milk. First, we need to change this into 3 equations. 2x plus 3y plus z equal to 44 for x raw. 4x plus 2y plus 2z equal to 56 for cake flour raw. X plus 5y plus 3z equal to 70 for milk raw. After we get the equation, we need to change it into augmented matrix and then perform ERO. For this matrix will be R1 minus R3 to get new R1, which is 1, negative 2 equal negative 26. The other row will stay the same. Next is 1 over 2 R2 into R2. Then we will get new R2. 2, 1, 1 equal to 28. Next, R3 plus R1 into R3, so 2, 3, 1 equal to 44. Then R3 minus R2 to get new R2, 0 to 0 equal to 16. Then 1 over 2 R2 into R2, so 0, 1, 0 equal to 8. Then R3 minus 2 R1 into R3, so 0, 7, 5 equal to 96. Next, R3 minus 7R2 into R3, so 0, 0, 5, 40. Lastly, 1 over 5 R3 into R3. And then we will get leading 1 and all 0 below leading 1. The last matrix is 1, negative 2, negative 2, negative 26, 0, 1, 0, 8, 0, 0, 1, 8. Now we can use back substitution. X minus 2y minus 2z equal to negative 26. Y is 8 and Z is at 2. Substitute the value Y and Z into first equation to get X value. Then we will get X is 6. Now we know with 44 eggs, 56 units of cake flour and 70 gallons of milk, we can bake 6 chocolate cake, 8 red velvet cake and 8 chocolate indulgence cake.
Oh, now I understand. Yes. From your calculation, we can make 6 chocolate cake, 8 red velvet cake, and also 8 chocolate indulgent cake, right?
Yes, Gaussian elimination method can help us to solve real-life applications such as our problem statement.
Let's make it home.
Alright.
Still want you all the time. 아직 내 맘속 한켠의 방에 그리움으로 가득 채워 너를 기다려 Need you all the time. 아무 말도 전하지 못.
In conclusion, the Gaussian elimination method is a fundamental tool in linear algebra, known for its efficiency in solving systems of linear equations. Its broad applicability extends to various fields, making it a cornerstone of both theoretical and applied mathematics. By transforming complex systems into simpler, solvable forms, Gaussian elimination enables precise modeling and also problem solving. This method supports advancement in technology and science, offering a systematic approach to optimization, data analysis, and simulation of dynamic systems. Its reliability and versatility ensure its continued relevance and importance in addressing real-world challenges, highlighting its role as an essential component of modern computational techniques.